The Curiosity rover, a remarkable feat of engineering from NASA, has recently captured stunning panoramic images of the Martian landscape, revealing one of the planet's most intriguing enigmas. On a clear winter day, the rover positioned itself at a lookout point nestled in the foothills of Mount Sharp, a towering mountain that rises approximately 3 miles high. From this vantage point, Curiosity was able to survey the expansive floor of Gale Crater, where the ancient river channel known as Peace Vallis is located. This channel is believed to have once transported water into the crater billions of years ago. What's fascinating is that despite the vast distance of about 140 million miles that separates Earth from Mars, Peace Vallis exhibits features strikingly similar to river drainage systems found on our own planet. However, the exact processes that shape this alien terrain remain a mystery. Some scientists propose that the water could have originated from rainfall during a time when Mars was warmer and wetter, while others suggest it might have come from melted snow or even underground springs. The latest images, taken from a distance of around 19 miles, showcase rocky formations and sedimentary patterns that have never been observed before. NASA noted while Curiosity has previously photographed Peace Vallis. This is the first instance where such intricate details have been captured within it. The image featured at the beginning of this article is just a segment of a much larger panorama. To create this expansive view, NASA's Curiosity rover transmitted 44 individual frames back to Earth, which were then meticulously stitched together. The colors in the final image were adjusted to reflect how the scene would appear under Earth-like lighting conditions. In addition to the panoramic shots, the rover employed its ChemCam instrument, a black-and-white camera that operates similarly to a small telescope, to examine distant features. This instrument captured Peace Vallis in 10 frames, which were also combined to produce another detailed image. The dark formations visible just left of center in the image are rock structures that add to the geological narrative of the area. These new observations are crucial for scientists as they seek to understand how sediment was deposited into Gale Crater and the duration of this process. Such images can provide valuable insights into the original sources of water that may have existed on Mars. Once upon a time, Mars was not the cold, barren landscape we see today. It was a vibrant world with rivers, lakes, and possibly even oceans. Over the years, researchers have uncovered substantial evidence indicating that the planet was once capable of supporting life. But the timeline of when water disappeared, the reasons behind it, and how long conditions remain suitable for life are still open questions. Scientists theorize that water and sediment once flowed through Peace Vallis into Gale Crater, creating a fan-like distribution of sediment across the basin floor. Since its launch in 2011, Curiosity, a mobile laboratory roughly the size of a Mini Cooper, has traveled an impressive distance of about 352 million miles through space, with an additional 22 miles traversed across the Martian surface. Investigating the history of water in Gale Crater is a key aspect of its mission to determine whether Mars could have ever supported microbial life. Interestingly, many researchers are increasingly optimistic that microorganisms may have existed on Mars. Recently, NASA held a press conference regarding a rock sample collected by Curiosity's sibling rover Perseverance at Gale Crater. This sample contains fossilized materials that could potentially indicate ancient biological activity, although officials caution that alternative non-biological explanations cannot be ruled out. Nikki Fox, NASA's associate administrator, remarked, "This finding by our incredible Perseverance rover is the closest we've actually come to discovering ancient life on Mars." Currently, Curiosity is exploring a mysterious Martian region known as a boxwork, which spans between 6 to 12 miles. This unique landscape features a grid-like arrangement of ridges, and scientists speculate that these formations may have developed from the last remnants of water in the area before it ultimately dried up. However, the presence of mineral veins within the boxwork raises questions about the timeline of when groundwater may have disappeared, adding another layer of complexity to our understanding of Mars' geological history.